Hello students. All right, today we are going to look at 11.1 antibodies. And here are our essential understandings. Plasma cells secrete antibodies, and antibodies then aid in the destruction of the pathogen. So let's remember from when we covered clonal selection, which was a very detailed video lesson that I hope everyone watched. Let's remember that lymphocytes, which are a type of white blood cell, these lymphocytes are either going to make T cells or B cells, right? So let's focus on the production of these B cells here. Oops, B cells. I can't write, goodness. B cells. And these B cells are then going to make either plasma cells, or these B cells are also going to make memory cells. And these plasma cells are in turn going to make antibodies. So we know that these B cells have the capacity to make both these plasma cells and B cell and memory cells. But we know that antibodies is part of a short-lived immune response, whereas we also want these B cells that are triggered by this antigen to also make memory cells, which is part of the long-term immunity that we want. Okay, so this is something very interesting, that plasma cells will secrete 2,000 antibody molecules per second into the bloodstream for roughly 4 to 5 days when they are introduced to a particular antigen. So I kept thinking about that when I got the COVID vaccine, right? The COVID vaccine allowed my cells to express the protein of the COVID receptor. And then my plasma cells started making antibodies, and it started making 2,000 antibody molecules per second for about 4 to 5 days, and that's why I wasn't feeling very well, at least the first couple of days. It is my hope that in addition to these plasma cells, my immune system is also continuing to make memory cells, right? So that I can continue fighting off COVID in the future. All right, so how do these antibodies work? We know that these antibodies aid, keyword there, aid in the destruction of a pathogen. But the antibodies, think of them as like these non-violent cells of our immune system, right? They're going to help, but they're not really going to do the actual destruction. So when we look at their mechanism for helping our immune system, think of the mnemonic panic. Okay, panic. And this is what antibodies do. They undergo, well, not themselves, but they aid in the precipitation of pathogens, agglutination of pathogens, neutralization of pathogens, inflammation of pathogens, and complement activation to destroy pathogens. Right? So remember panic. This is how antibodies aid the destruction of pathogens. So let's look at this picture here, what each of them do. So remember I told you that antibodies are like these non-violent, right? So antibodies are only going to aid or help in the destruction of the pathogen. But it's really these macrophages, right? So let's define what a macrophage is. A macrophage is a phagocytic leukocyte. So a leukocyte is a word to define white blood cells. And there's different types of white blood cells in our body. Now, these macrophages are a type of white blood cell, and it's phagocytic, meaning that it can engulf, swallow, and destroy anything that is foreign in our bodies. Okay? So the antibodies, and we're going to look at antibody shape and structure in the next slot, in the next video lesson. But we always think of them with this shape, right, as a Y. And what do these antibodies do? Well, they'll make soluble antigens turn insoluble. So that means that they precipitate and they're easier to target and find. And so that these macrophages can swallow it. Okay, so opsonization and phagocytosis means that these macrophages are targeting it, find it, and then swallow it and destroy it. Agglutination means that the antibodies are going to find the pathogens and then they're going to clump them together so that, again, these macrophages can find the pathogen and destroy it. Antibodies are also going to undergo neutralization. So that means that they're going to take the pathogen and they're going to neutralize it. So any part that is cytotoxic or any part that releases toxins, it's going to neutralize that part so that then the macrophage can destroy it. The antibody is also going to trigger histamine release. So then that means that histamine release means that our antibodies is going to tell certain cells in our body, mast cells, hey, there's something going on here. Start an immune response, and this immune response is inflammation. So when these mast cells release histamine, it's going to start this inflammation process and it's going to increase immune mobility, meaning that our white blood cells are going to be on alert, that there's something going on, right? That it's time to act. And then the antibodies, what they're also going to do is what happens is they target the pathogen and they act like these markers for another protein called complement. And then what this complement protein is going to do, this complement protein is going to lyse the cell membrane of the pathogen. Complement immune reaction it's a kind of complex reaction here where these molecules known as perforins are going to like shoot out of this protein complement molecule that's been induced by the antibody, right? The antibody's kind of like over here, and then the complement is going to lyse or burst the pathogen. Remember, this is a pathogen, this is the bad guy, membrane, okay? And that's what we know as cell lysis. Okay, so that's how antibodies are going to work, and that's how they're going to help in the destruction of these pathogens, right? And again, this is short-lived because this is something that's happening when the pathogen is present in our body. But like I said many times, we want these we want these B cells to also make memory cells, right? So that if we ever get infected with the pathogen again, we can elicit an immune response once again, and these antibodies can go and act once again. Okay, so that is it for antibodies.